Hello, my name is Ryan Nienhuis. I'm a Senior Product Manager at Amazon Web Services. Today we're going to be talking about real-time decision support when speed and analytics meet. What we're going to cover is an overview of what real-time streaming analytics is, and also what streaming data is and how it relates to getting valuable information from your data quickly. We'll cover some key use cases about getting information from your data quickly using streaming data. We'll talk about one of Amazon Web Services Kinesis Data Analytics, as well as a set of services under the Amazon Kinesis umbrella that we've launched a set of solution accelerators for that allow you to get started in minutes getting information from your data in real time. And then we'll end with a call to action, some follow-up materials for you to either learn more about the services that we provide that perform real-time analytics, or even get your hands a little bit dirty and try out a couple of technical solutions. So overview of real-time streaming analytics. So let's first start with what we mean by streaming data, and that Amazon, specifically the Amazon Kinesis team that deals with a lot of streaming data, the way we like to think about it is it's not necessarily the type of data that you're ingesting or processing or some category of data, but it's really how you act upon it that makes data streaming. So a good example of this, very simple layman's example, would be you have videos. You can have a video on a DVD or Blu-ray, but in reality, most people nowadays are consuming data in the streaming format. In the data, and when we say the streaming format, data that is continuously captured, processed, and stored, or reacted upon. So for video, you can think of any one of your online video providers. For data, you can think of, say, log data. So in the old world, the way people ingested log data into centralized solutions is they'd maybe have a logging agent that sits on a piece of hardware or an EC2 instance that is storing the log data to disk, and then periodically wakes up maybe every minute or every hour or maybe even longer than that, and then send data to some centralized store, maybe Amazon S3 or a centralized logging solution. Data is streaming if you do the capture of it and storage of it and processing of it continuously and in real time or near real time. So instead of a daemon waking up and sending a piece of data over some fixed period of time, you'll be, as the data is being generated, or as close to as possible as the data is being generated, you'll be sending that data to a streaming service and storing it. And then you'll be consuming that data from a streaming service and processing data on the fly. In order for you to get real-time analytics, perform machine learning on that incoming stream, generate alerts, perform actions, but also to do simpler things, just like getting the data into a centralized repository of information, like a data warehouse or a database or a data lake, relatively quickly. So getting data into those centralized stores instead of every hour, you're talking about minutes or seconds. Why would you want to do that? And the primary reason why you would want to do that is that data loses value quickly over time. So a good example for this is a business report that's generated, say, last week or even today, is much more valuable than a business report generated a year ago or 6 months ago or last month. And that's because the fresher the information is, the more valuable it is. Taking that to a little bit more of a real-time or near real-time use case or scenario is if a customer is browsing your either physical store or maybe your online store, is interested in your product, it's much more valuable to get react to their experience as they're shopping or as they're browsing your website for more information immediately as opposed to after the fact. That customer may be interested in a product and couldn't find it on your website, or some piece of information that helped them make a buying decision and couldn't find it, and ability to be able to detect that and respond to it in real time or near real time is much more valuable than to find out with some analytics after the fact that, hey, this customer churned and we think it was because they couldn't find the information that they wanted. So I give you the context of streaming data, that it's all about speed, getting information from your data more quickly. What are some common scenarios or use cases of streaming data? So we see a lot of streaming data use cases in the smart home or smart city setting, meaning that either in the consumer or in the industrial space, Customers are ingesting data, IoT data from IoT sensors to consumer electronics to mobile phones. Very, very common that we see customers use streaming data. And the value there is quite obvious, but it helps us to restate it. Getting information about what's going on with the device and reacting to it is significantly more valuable than finding out a device was down for hours after the fact. Common use case is log analytics, and logs are a pretty broad topic, but when I say logs, I typically mean logs from either human-generated logs or machine-generated logs. So when I say human-generated logs, this is a clickstream data from mobile phones, mobile applications, maybe mobile games, clickstream data from your mobile website. It could even be a business event generated by a user. So a customer changing some account information, or a customer progressing to the next level of your mobile game. It can also include system information, so operational logs or application logs. So server-side events about activity, about Apache web server logs, things that indicate performance health. It's a very common use cases for streaming. Many customers use streaming services in connection with operational solutions to meet their needs if they're sort of monitoring their end-to-end applications. We're increasingly seeing customers use streaming data in the context of data lakes, and this has been since we launched services that speak to streaming data several years ago. And it's basically, the goal of it is just to get data into your data lake in a format that's more easily consumable and faster. So performing what we call streaming ETL, so ingesting the data, transforming it on the fly, doing everything from simple format translation to very complex enrichment, correlations, and aggregations prior to the data arriving in your data lakes, data warehouses, or databases. So Amazon Kinesis is a set of services at AWS, 4 services, that make it easy for you to capture, ingest, and process streaming data in real time. It's a foundational service used across Amazon. So the AWS metering service uses it to ingest metering records and billing reports into the billing system. So for your Amazon Web Services bill, the way that's generated is each service has a metering record that indicates usage. That metering record is quite fine-grained. So for example, AWS Lambda bills sub-second, right? Those records are aggregated, sent to aggregated through Amazon Kinesis, and eventually end up in your bill. So quite an extreme scale of solving the problem of getting data to your bill very quickly, aggregating a bunch of very, very small records into a larger piece of meaningful information. Amazon CloudWatch Logs, under the covers, uses Amazon Kinesis data streams. They use it, again, solving the problem of how do I ingest a large volume of small events continuously and in real time or near real time. Amazon Go, we have a service that we launched at the end of last year that's focused on video that we'll cover on the next slide. But Amazon Go uses Amazon Kinesis video streams as part of the way they allow customers to go in and purchase goods without actually going through a transaction with a cashier. So streaming data with Amazon Kinesis. So we're going to focus on the data services. I just mentioned Kinesis video streams, but Kinesis data streams allows you to capture, process, and store data in real time. It's the first service we launched more than 4 years ago at AWS reInvent. The service provides a lot of flexibility with how you write data to a stream and consume data off of a stream. It's a core infrastructure service, as I mentioned on the last slide, used by many of internal services as well as lots of external customers. The primary value is how do I get a large volume of data that's continuously generated into AWS or from other AWS services to other AWS services efficiently. And this is the problem that Kinesis Data Streams provides. Kinesis Data Firehose was a service that we launched, I think, almost 3 years ago now, and it solves one of the core use cases for streaming data. So we're going to talk a lot about responsive analytics and doing a lot of sophisticated processing, but one of the most common scenarios for streaming data is moving data from point A to point B. So Kinesis Data Firehose provides that. It allows you to write data to Kinesis Data Firehose delivery stream at a high volume, and then deliver it to a configured destination, like Amazon S3, Amazon Redshift, Amazon Elasticsearch Service, or your own Splunk clusters. Kinesis Data Analytics is the last data-oriented service. It allows you to analyze data that's flowing through Kinesis data streams or Kinesis Data Firehose in real time. Most customers use Kinesis Data Analytics for the continuous generation of business or operational metrics, or for responsive analytics, like detecting a change or a trend in a metric or a valuable piece of information, and then reacting to it in real time, maybe sending notifications, triggering alarms, that type of thing. So a little bit deeper on Amazon Kinesis data streaming. This is how the services work together, and they can be plugged and played in different ways, but oftentimes customers will ingest data using Kinesis data streams, process it using Kinesis Data Analytics, and then maybe deliver it to one of the destinations I mentioned using Kinesis Data Firehose. This is one pattern, high-level pattern that can be followed. The services can be used relatively independently as well, or in different combinations. For example, you can attach a Kinesis Data Firehose directly to a Kinesis data stream, if that's what you want to do with one of your applications that read data off a Kinesis data stream. The other pattern that I want to emphasize here is, like, we have data producers that write to a stream, and there's lots of options to read data from a stream. So Kinesis Data Analytics is one, but the Amazon Elastic MapReduce service and Apache Spark is another. Amazon SageMaker, Custom Code on EC2, and AWS Lambda are also very popular solutions. Regardless of the solutions that you choose, all of these solutions are real-time, fully managed. Many of them are serverless, but all of them are scalable and elastic. They're all very secure, and we offer features like server-side encryption, compression, encryption upon delivery that make the services secure, and they're all cost-effective. Data Streams is a service that allows you to ingest data from a set of data producers, and those data producers can be almost anything from a mobile phone to a web client to an application server. And typically those data producers are in the tens of producers. So there's tens of EC2 instances, to the hundreds of mobile phones that are live outs, to the tens of thousands or even hundreds of thousands of connected devices that are all writing data to Kinesis data stream. What makes the Kinesis data streams unique is its ability to efficiently ingest data from all those sources very, very quickly in real time. So it's a very high throughput, high volume store that allows you to ingest data into the AWS cloud or from other services from the AWS cloud. It provides a lot of flexibility with the tools that I mentioned. So I mentioned Kinesis Data Analytics. One of the other more popular solutions is we have an open source library called the Kinesis Client Library that solves a lot of hard problems like fault tolerance and load balancing that customers run on Amazon EC2. But if you prefer a serverless option, AWS Lambda provides a great option for sort of discrete event processing. So things like filtering, taking specific actions on specific events, like perhaps a specific business event associated with a customer comes in and they need to, say, update their account information. AWS Lambda is a great tool for that. The takeaway from this is that Kinesis data streams is a very flexible way to get data into and out of the AWS cloud and into other AWS services very, very quickly and efficiently. So I mentioned Kinesis Data Firehose solves sort of one fundamental use case of streaming data, and that's moving data from point A to point B. So if you don't have to do a lot of heavy processing, or you don't want the flexibility to sort of build your own apps and write your own code, Kinesis Data Firehose provides that to you. Its primary purpose is to ingest, transform, and then deliver data in real time to various AWS services and Splunk. So there's a lot of different ways to ingest data into Kinesis Data Firehose. Some of the most popular include the Amazon Kinesis Agent, which is a logging agent we produce. The AWS SDKs allow you to put or write data to a Kinesis Data Firehose. In addition to that, there's a lot of different automated ways to ingest data into a Kinesis Data Firehose. So CloudWatch Logs provides a logging service. For those of you who are not familiar with it, there's a simple subscription feature called Subscriptions, where you can forward all data to Kinesis Data Firehose to be ingested and delivered to a specific destination. CloudWatch Events allows you a lot of flexibility forward things like, example being CloudTrail logs, so information about your AWS account activity to a Kinesis data firehouse. There's also a connection with AWS IoT and IoT hubs. This is true for both Kinesis data streams and Kinesis data files. So you can use IoT like an MQTT broker. So to ingest data and then forward it to different services, Kinesis and IoT are often used together. We also have an Apache Kafka connector that allows you to write data to Kinesis data files. One important context is that everything on the left-hand side, with the exception of Amazon Kinesis data streams, you can also write to an Amazon Kinesis data stream. And a lot of times we get the question, what's the difference between Kinesis streams and Kinesis Firehose? So both provide a write API. Kinesis streams provides a read API that's publicly accessible that allows you to write an application to consume data off of the stream using any tool that you choose. Kinesis Firehose does not provide that, and it's really primarily focused on the delivery from point A to point B. We also allow you to attach a Firehose as one ingestion method to a Kinesis data stream. This is for customers that say, I would like to write my own application, and I want to write my own code on a stream to consume and process that data in real time, but I also want it delivered. So they'll attach one application to a stream that does maybe some responsive analytics processing, and they'll attach a Kinesis data Firehose that's perhaps just archiving all the data from the stream into Amazon S3. From a transformation perspective, we offer a number of pre-built transforms built right into Kinesis data Firehose. They include compression, encryption, some format translation, as well as if those automatic transformations that don't meet your needs, we provide a way to do streaming inline processing using AWS Lambda. So if you need to run a script to do, say, take a custom format that you have and convert it into a format that you want to store into your data lake, if you want to do simple enrichment or other types of processing, AWS Lambda provides a way you to run a piece of code in a serverless environment to transform the data prior to delivery. We deliver to 4 different destinations, so Amazon S3, Redshift, Elasticsearch, and Splunk. Each of these have different configuration options, but the most common ones are things like, how long do you want us to buffer data prior to delivering to Amazon S3? So for example, you could deliver data once a minute, or you could deliver data, every 30 minutes. You deliver data in a couple megabyte file, or maybe even 100 megabyte file. So customers that are used to streaming data, another common question we get is, why wouldn't I just write directly to these services? So imagine if you had, tens or 20 or 30 or maybe even 100 EC2 instances, and they all writing individually logs to Amazon S3. Or you have 1,000 different mobile phones, mobile clients that are running at a given time, and they're all running to S3. And I could go further to say 10,000 or 100,000 different clients trying to write. What you end up with is a lot of different tiny files that are hard for batch processing tools to both handle and ingest, as well as process it after the fact. Example being, you don't want to write to Redshift in a bunch of individual writes into high-vol, like a petabyte scale data warehouse. What you want to do is you want to buffer that data for a little bit. So turn those tiny sub-kilobyte records into larger files that these batch processing tools can more easily deal with. But you want to do so quickly and efficiently, and maybe you want to transform data on the way. Kinesis Data Firehose provides all the mechanisms in order to do that. Kinesis Data Analytics is the third Amazon Kinesis data service that we launched. Data flowing through Kinesis Data Firehose or Kinesis Data Stream can be processed with standard SQL in in Kinesis Data Analytics. So customers build applications that are defined by a set of SQL queries, one to many of them, that process the data to perform typically one of 2 use cases. So the first use case is the continuous generation of business or operational metrics. Business metrics like the number of page views on my website or the number of customers going into a specific scenario. Operational metrics like everything from like percentiles of a key, like error messages, percentiles of errors for a particular API, to calculating the average payload for a particular request, to advanced analytics like performing machine learning on network logs. So Kinesis Analytics provides a mechanism to do all of that. This type of use case is typically implemented in front of databases or operational software for both a speed, flexibility, and cost reasons. So with a large stream of events coming in either hundreds of events per second or thousands of events per second, say, you could insert that data into, say, a database like a DynamoDB table or an Aurora table, and store all of those events in a raw format and then take a series of ETL steps to get to useful information. Or alternatively, a lot of customers use Kinesis Data Analytics to basically, instead of storing the raw data, they only store the valuable information. So instead of storing 1 million events, they store 1,000 or a couple thousand valuable pieces of information that they've aggregated ahead of the database. So obviously that has cost ramifications. It also has performance ramifications, and then it also has speed ramifications. So instead of performing all those slower ETL steps, you've got the flexibility to do advanced processing on the fly, and then insert it into a database, into an end user table that's immediately available to query upon from end users or applications. The same is true for the operational metrics use case. So customers use Kinesis Data Analytics in conjunctions with Amazon CloudWatch or other operational tools, primarily either to get more advanced analytics like machine learning out of it, or to produce those analytics faster, and or just to reduce the cost, to reduce the amount of data that needs to be sent, since you're sending information that's already aggregated. The other top use case for Kinesis Data Analytics doesn't differ much in sort of the processing, but differs what you're actually doing with data. Instead of the primary action to being, store the data a minute after it was generated and it's valuable information, the primary action is to react. So customers they might calculate the average temperature of an IoT sensor, and they might have a threshold that they have on that, or a specific scenario, such as like, if this temperature reaches this point, and the sensor is in this state, and the sensor has been in this state for a certain period of time, then send a notification for someone to go fix the machine. Things like that use case. There's responsive analytics. So where you're implementing use cases that are reactive, so sending notifications, triggering AWS Lambda functions, maybe writing to another Kinesis data stream or an SQS queue. But the key there is to react. There's very real-time use cases. So there are a lot of customers that are using Amazon Kinesis. Here are a select few. There's one that I'll draw your attention to. They just spoke at the AWS San Francisco Summit. Synca. They were doing real-time game events as well as operational log events using Amazon Kinesis data streams and Amazon Kinesis Data Analytics. They're trying to get faster and better visibility into what's going on with the games that they have, that their customers playing their games. Another great one is Nordstrom. Nordstrom has online stylus processing with over 10 million events per day. They're improving their customer experience in real time by using Amazon Kinesis. So they use Kinesis data streams in a lot of different contexts. One of those contexts is to analyze events coming from their website, the clickstream, to sort of optimize the customer's experience. Hearst Corporation is another great example. Hearst Corporation owns a large number of both prints as well as online publications. One of the great things that they do is aggregate data across those publications to determine what trending articles are occurring. So maybe if one of their sites has a popular article that's going viral, they're able to take that article and publish it across many of their websites, effectively doubling down on something that's popular. I guess it's hugely valuable that they find that information, minutes or hours after it becomes popular, not the next day. So one use case that I'm going to focus on is YieldMo. YieldMo is a digital advertising technology company that helps marketers and publishers build deeper engagements with their customers. They're using Amazon Kinesis to basically get detailed information about their users in real time and the ad impressions that they serve those users in real time. But this use case is applicable broadly to anyone who has wants to get a deeper understanding of their customers faster and in a more granular fashion. So what YieldMo is doing is that they're analyzing the way customers interact with their ads and the pages that their customers that they serve those ads on in milliseconds, with granular things like how long is a particular pixel visible on a website for a given user. And these types of engagement metrics allows them to give their customers better ad performance as well as deeper engagement on their ads. So delivering more relevant ads to customers that customers actually care about. It also allows them to optimize ad placements. And the reason why streaming data is important and Amazon Kinesis is important for this use case is when you're talking about that granular of measurement and that fast of measurement, streaming data is really, really a nice fit for the solution. So you're capturing, hundreds of thousands of events per second, processing them in real time, and analyzing them, performing a lot of pre-processing ahead of their data warehouse to aggregate data in that use case I mentioned earlier, that pre-aggregation use case. So if we look at like a very, very 1,000-foot view of their architecture, they have website visitors that visit the websites that they're serving their ads on. This data is ingested into Kinesis data streams, in which they have a number of Kinesis data analytics applications reading from those streams, using SQL to produce advanced metrics like sessionization and the pixel count metrics that I mentioned. So for those of you not familiar with sessionization, it's applicable both in the ad market as well as anybody who operates a website, even applicable in like IoT and other use cases. It's basically correlating events that, in this particular case, correlating events of all the events that are associated with a user visiting a website for a given time. So you might visit a website and be on that website for maybe a couple minutes, maybe even an hour. You need to be able to sessionize that and correlate all those events to get metrics like how long was the user there, or how long was the user on a specific page. Amazon Kinesis Data Analytics allowed that YieldMo to build some very innovative analytics on top of it, this type of on top of Kinesis Data Analytics, like these sessionization metrics. Then they use Kinesis Data Firehose to deliver data to S3 as well as their data warehouse, and from there they do some further analysis. That it's important to say like what is Kinesis not good for. So if you're trying to analyze data over months of periods of time, or you're trying to analyze data over weeks of period of time, those are really the bread and butter of batch analytical tools and data warehouses. Kinesis Data Analytics in this architecture, the primary purpose that it provides, as well as the entire Kinesis platform rather, the primary value prop that it provides is that it's getting data, transforming it into information at a very, very high volume, and then sending it to the data warehouse in, say, less than 5 minutes. But instead of sending, tens of thousands or hundreds of thousands of events per second to the data warehouse, they're sending 1,000 very useful pieces of data once a minute, or 10,000 pieces of valuable information once a minute. So they're drastically reducing the amount of data they have to store, as well as when it's sent to the data warehouse, it's immediately available to query. So it's immediately useful to the end user. So, excuse me, Amazon Kinesis and our team has worked on a number of solution accelerators over the past couple months that make it really easy to get started and follow some of these common use cases and patterns that I've described over the, the past 30 minutes or so. So AWS Answers is the mechanism in which we publish these solution accelerators. For those of you unfamiliar, AWS Answers is an initiative that Amazon has to basically provide clear answers to common questions and common problems that you have around architecting and building apps on AWS Cloud. Every one of these answers includes a marketing page that describes the problem and the answer at a high level, sort of a 1,000-foot view. It provides a CloudFormation template for you to start with the pre-built solution, either which may work great for you out of the box, or you may want to customize it for a little bit to suit your needs. But the point is you're able to get started with a couple clicks and oftentimes not a lot of code or no code at all. And then implementation guide that goes into a much more detailed view of like how to customize, how much you can expect it to cost, what services are involved, what value do those services provide, that type of thing. So the Kinesis solutions specifically that we provide, actually let's back up. One important thing that I want to mention is the AWS Answer provides this solution. These types of solutions offer a very broad set of problems. So everything from like security to big data to account management to log analytics. So it's a great resource if you have a problem that you're trying to solve on AWS but don't know where to get started. The Kinesis solution specifically that we've built, they enable you to test out a streaming solution in minutes. A lot of times, even if you don't already have streaming data available or you think you don't have streaming data available, we automatically pull from AWS sources that you probably, that can be processed in the streaming context. And we'll get more into that later. The majority of the solutions are serverless and elastic. One of the solutions that we shipped, we decided not to be serverless, and I'll talk about why. They provide basically end-to-end template, and they offer everything from real-time analytics to basically delivery to batch analytical tools. They also, the majority of them include some sort of machine learning, so like anomaly detection. So if you haven't tried out machine learning, a lot of these, especially machine learning in real time, which can be a little bit harder, a lot of our solutions include algorithms that work out of the box for some of the answers that we have. And if you haven't, if you want to get your feet wet with this type of thing, it's a really easy way to do so. The final thing I want to mention is that you should use these solutions as a starting point. Some of you will find them like immediately valuable and like as is. Like this is great, serves a great purpose for me just without any changes. But the majority of you are going to want to customize and mix and match, as well as just use it as sort of an educational starting point on your journey to implement new streaming data use cases. So one of the first ones that we have are real-time insights on AWS account activity. The link for that is at the bottom of the page, and it comes with all of the parts of the AWS Answer solution that I mentioned earlier. So end-to-end, what we're trying to accomplish here is basically provide you useful information about what's going on with your AWS account. This solution is meant to be customized such that you can, there's specific information that you want to get out, like for specific resources, creates and deletes are important to you. And or you want to find out if individual accounts are executing on a specific behavior over and over again. So maybe like you're expecting an AWS account to create n number of resources, and these are the different resource types at a given part of any given day. This will allow you to track that. So there's a lot of flexibility, and there's a lot of different reasons why you would want to monitor what behavior of your AWS account activity. They're everything from security to compliance to operational reasons. And AWS Cloud Shell logs API calls associated with your AWS account from the console, SDKs, and they provide an initial mechanism for you to do so. The way we get them into a Kinesis data firehose is we use a feature of Amazon CloudWatch called Amazon CloudWatch Events that allow you to basically trigger events that are coming from point A to point B and send them to different AWS services. In this case, we're sending them to Kinesis data firehose, which I mentioned part of the job of what firehose provides is deliver data to point A to point B. So delivers data to that S3 bucket, and that's for archival purposes. If you want to ever look at the raw data, it does so. The other thing it does is it exposes it to a Kinesis data analytics application. So, and we compute a bunch of interesting metrics right out of the box, things like hot and cold IP addresses, hot and cold service creation. So if you're spinning up a bunch of EC2 instances, all at once we'll detect that type of thing across all of your AWS services. So it's sort of very high-dimensional cardinality data. We then use Kinesis data stream and Lambda function to deliver that to a DynamoDB table and drive a quick and dirty real-time dashboard off it. So the dashboard that we have, in order to keep this relatively inexpensive and quick to use and limit the number of AWS services that we have, we basically are building this nice dashboard off of Amazon S3 that pulls data dynamically from Amazon DynamoDB. So for customers using the solutions, we've had some that just customize that dashboard right out of the box because it provides some interesting data for them, and they only care about 4 or 5 metrics, and the JavaScript libraries that we ship with them work great for them. Others replace this step with maybe the Amazon Elasticsearch service for visualization in Kibana, or they send it to Amazon QuickSight for a more robust BI tool. to visualize it, or they send it to whatever BI tool that they're running. This is just one implementation that we're following, but it does follow some great best practices. Specifically, in the Lambda code, we have a lot of best practices to how to load a DynamoDB table with streaming data. In Kinesis Data Analytics, there's a lot of great SQL code examples of how to process an incoming data stream. All of these solutions provide best practices. This solution, you can get started in less than 5 minutes and get the real-time dashboard on your AWS account activity. So definitely encourage you to try it. It's definitely one of the easier solutions to try out. So real-time IoT device monitoring with Kinesis Data Analytics. So this is follows a very similar pattern to the last one. The ingestion into Kinesis data files is different in the sense that we set up an IoT rule to forward data to Kinesis data files. Also, the metrics that we compute are obviously very different than the account activity solution. The metrics that we compute are things like how long a device has been connected for, when was the last time the device was connected, what is the average fluctuation of some common metrics. And the SQL code is designed in a flexible way to allow you to get real-time metrics really easily and for your specific IoT sensors. So they're written in a way that it's very easy to add and remove different metrics. At this point in time, when I talk about analytics and IoT, we often go to the question, especially recently, that AWS recently launched IoT analytics, and we're talking about doing real-time analytics with Kinesis Data Analytics on IoT data. When would I use one versus the other? And my answer for you would be a lot of customers, there's a lot of overlap between customers using AWS IoT and customers using Kinesis. And the reason why is because we solve a fundamental problem. Kinesis does, and AWS IoT also solve fundamental problems that are associated with IoT. So how do you get a high volume data into the AWS cloud efficiently? How do you expose it to lots of different analytical tools? Specifically with Kinesis Data Analytics, the IoT customers we see implement applications in Kinesis using the service are really focused on IoT sensor data, sensor monitoring. Usually they're integrated with an operational metrics dashboard, or they're trying to very quickly get data, the information from the data to get to a database. So very focused on the real-time or near real-time. Whereas IoT analytics, at least right now, is primarily focused on the near real-time to the more historical ad hoc analytics. But if you're an IoT customer, it's likely that you use some combination of IoT and Kinesis services. So real-time web analytics with Kinesis Data Analytics, this is another different sort of ingestion path. And this is the first one that we have that's not completely serverless. And the reason why we provided this example is because, serverless is definitely becoming increasingly unpopular. It's already very, very popular. But at the end of the day, a lot of customers still run Amazon EC2 for a variety of purposes. And one of the most common ingestion mechanisms into a Kinesis data stream or a Kinesis data files is an EC2 instance and a logging agent. So we have one of our open source libraries called the Amazon Kinesis agent set up in this solution to log data from basically Apache web servers. So for customers use these web servers in a lot of different contexts. So example, they're usually doing something else. It's usually not just primarily just ingesting into a stream. So for example, if you're a mobile game company, these might be your game servers that are doing the primary player-to-game interactions. If this is for your retail website, it'll be those. If it's to run your business application, it'll be those. So anything that's generating logs. So here, we're generating these real-time analytics. We're doing some very basic but important metrics. So things like page views by individual users, number, like average stay time, that type of thing. So some interesting metrics in the computation, and then providing that real-time dashboard. Again, the solutions are meant to be customized. This whole solution for the majority of customers for actually quite a lot of scale is going to be less than $100 a month. So relatively inexpensive. But what we'll find is that you go try out one of these solutions, and then you'll mix and match. So maybe you don't want to send to DynamoDB, but you want to send to Aurora instead. Or maybe you don't want to use the dashboard that we created. Maybe you want to use CloudWatch dashboards. So with that, the first set of solutions we worked on this year are really focused on that pattern to get the data to Dynamo with a custom dashboard. It follows that we tried out different ingestion mechanisms, different types of analytics to be computed, but the second half of the architecture where the data ends up is relatively the same. We are starting to release, I think this one is coming in June, to the AWS Big Data blog, and eventually will be published on AWS Answers, solutions that vary a little bit with what happens on the backside of this. So in this particular use case, we're analyzing VPC network traffic coming from Amazon VPCs. There's a great feature of Amazon CloudWatch called CloudWatch Log Subscriptions that allows you to forward data to Kinesis data streams and Kinesis data fire hoses. So this feature allows you to ingest data about your network traffic going into and out of your VPCs into Kinesis. So we have two paths for this. So the first path is we attach a Kinesis data analytics application to process data and generate useful metrics about VPCs. So are there hot IPs? Is there particular request paths that are trending, or maybe perhaps they're anomalous? And then we publish that data to Amazon CloudWatch. We also have a great start for Amazon CloudWatch dashboards. So for those of you familiar with it, unfamiliar with it, Amazon CloudWatch provides a set of a tool called CloudWatch Dashboards that allows you to build custom dashboards off of CloudWatch metrics. There's been a lot of innovation and iteration that's gone into the service, this capability over the last year or two. So we give you the start of a dashboard that can be easily customized. And the way you would customize it is you'd change the SQL code to generate a metric that you care about, or maybe you care about anomalies coming from a specific IP address, or you care about the specific operational metrics coming from a specific HTTP request in some manner or form. So you'd compute that, and then you'd add the metric to CloudWatch and the dashboard. So it's a very easy, like 5-minute process to add a new metric. Amazon Kinesis Data Firehouse here on the other path is delivering this data to S3 formatted in Parquet and ORC format. I'll go into the next slide a little bit what that means, but Firehose recently announced a feature that basically will now deliver data to S3 in these two formats, which make it very efficient for you to query them using Athena or Redshift. So speaking of that, as of 5.10, we shipped a new feature that allows you to use Firehose to deliver data in Parquet or ORC format into S3. It uses AWS Glue, our ETL service, specifically AWS Glue data catalog for the schema definition, so how the data should look like in S3. Apache, Parquet, and ORC formats are columnar data formats that allow you to store and query data efficiently. So a lot of customers use these formats when they're using Amazon Athena, our service for querying data on S3, Amazon Redshift Spectrum, which allows you to process data on S3 from your Amazon Redshift cluster. There's significant improvements to the query times, the efficiency in which you can do that ad hoc analysis using those services. We have a blog post that shows you how to do it. It's not one of the solutions that we're working on, but it does provide a CloudFormation template for a great example of how to analyze that data. So definitely I'd encourage you to try it out. So this is our last slide. I mentioned I'd end with a call to action. The first and foremost is just visit the Kinesis website. It's the top link on the top side. And then just for your convenience, I've included all of the solutions and websites that I mentioned previously in the presentation for you to try out. If I were to recommend one for you to try out really quickly, I'd recommend you the top one. If you want to go a little bit deeper into using the services, I'd recommend the last blog on the bottom there. It'd be a great introduction to the Amazon Kinesis Firehose news feature. So with that, thank you very much. We'll open it up for questions now.